This conference will now be recorded.
Okay, so we are discussing the distribution strategies, okay, or the distribution case. And yeah, as part of that, we are seeing that there are distribution strategies are like, distribution key or distribution dist key, all, even, and auto. So yeah, these we will be defining at the time of creating a table. Okay, when we will be defining at the time of creating a table, means as part of table DDL we will be mentioning. Okay, so all means oh yeah, what happens? All means entire copy of the table will be placed in the first slice of every node. Even means it will be distributed in a round robin fashion. Auto means actually, for example, if you don't know like whether to define key or all, then you can leave it as auto. Then it will automatically start with uh, all, and then if it says that the table is growing exponentially, then it will automatically change to even. But it's always better that you define the key rather than keeping it as a auto. So if you, I mean, generally, yeah, whenever a table is, I mean, coming into production, we will be knowing what is the column based on which it will be joined. So it would be better if you define the, not only better, it is best and it is required that you can blindly put joining column as the distribution key. Okay, so rather than keeping column which is most unique. Although the purpose of distribution is to evenly distribute, but you see, for example, you take the custom table, okay, customer table, okay, customer table, yeah, will have customer ID, customer name, and some fields related to customer, and it also will have something like order ID, okay, but order ID will also be unique in this customer table. Okay, so customer table, if it is 100% unique, order is also almost okay 100% unique, because orders will be different for every customer. So in that sense, instead of having customer ID as the distribution key for this customer table, it's better that we can have it as order ID as the distribution key, because order ID is used in the join. Okay, so why we should give more priority for the joining column to create as a distribution key is that will avoid data redistribution at the time of query processing. If you don't create, for example, I mean, what happens when we create customer ID as the distribution key or any column as a distribution key, data will be distributed on that column to all the slices. Okay, for example, you created, you see, there is something called timestamp, right? Timestamp is also unique. Why? Because timestamp will have, time is different from timestamp. Timestamp means it will have hours, minutes, seconds, that part. Date is different from timestamp. Date means you will have only, for example, today is how much, 5th August 2022, but today's timestamp, if you take 5th August 2022 column, hours, minutes, seconds, that also will display. So so now if I say what is the timestamp, it will be different. After again, if I say what is the timestamp, so timestamp will change, right? Because seconds will pass. So somebody may think that, sir, I can create a timestamp as the distribution key, but you can create, but it's of absolutely no use. Just because something is unique, you cannot create it distribution key. And similarly, for example, ATM transactions. Okay, so the transaction ID also will be unique. Transaction ID. because every time you insert a debit code or every time anyone insert a debit code, transaction will be generated, right? Whether it's fail or success or whatever it may be, transaction ID will be generated. Even if you enter some wrong pin also, or even you enter some wrong amount also, whatever you do, or if there is no cash also inside the ATM, you will get some transaction ID. So because transaction ID is unique, so people may say that I may create transaction ID as the no. Because what is the use of creating a column as a distribution key when it is no you when it's not used in joins? Absolutely no use. So you should know that the column which is used in the join should be given more priority for being a distribution key for a table. But it should be reasonably unique. Means it may not be 100% unique. It can be 80% unique or even 70% unique also fine. But 80% is generally ideal. Generally those columns will be unique. Okay. So or 80% unique. So no issue. Okay. So yesterday we have seen how the columns which are the tables which are distributed based on joining columns will help. How they help? Because the funda is, we know, right, what is inner join. So when I asked inner join and all, you people said inner join means matching records. It will bring the matching records from both the tables. And the left outer join means it will bring the matching records from both the tables plus remaining records from the left table. And the right outer join means it will bring the matching records from both the tables plus it will bring the remaining records from the right table. So yeah, in fact, last time Prasad asked, what is this matching records? Matching records means, yeah, you are joining two tables on the common column, right? For example, employee department table. Employee table will have employee ID, employee name, department number, salary, and department table will have department number, department name, location. So what is the matching column in both the tables? Department number. So these two values in this column should, then only you will get the record as an output if you do the join. So employee table on every employee, in every employee table department number column is there. So the department number value and in department table department number value should match. Then only you will get the output, that record. If it did not match, you don't get it as an output. That's why common column is required to join. For example, why you and me meet? I mean, for example, you are there, okay, and I am there. Why we are meeting? Because there is common interest. What is that? You are seeking Redshift training, I am giving Redshift training. So there is a common, there is something common. Then only if there is no common column, how do we join? Or if there is no common interest, how do we meet? I mean, obviously we don't meet. So similarly, as we already said while discussing primary key and foreign key, in order to join two tables, that common column is required. That common column is only we are referring as a foreign key. What is that foreign key? It's already existing as a primary key in one table. Okay, when it's used in another table, that will become a foreign key. So department number is already there in department table as a primary key, but it's also used in the employee table. So it will act as a foreign key for employee table. And since it is available in employee table and it's available in department table, so we will join based on that common column. So what happens if you have common column is, or here I will use, rather than saying common column, I will say the joining column. See, in employee table also it is joined based on department table, and the department table also based on joined based on department table. So what happens is, for example, okay, while department table is being distributed, okay. So for example, department number 10 is there, let's say, in employee table. So 10 is coming to slice 1, let's say, slice 1. The 10 value is coming. Okay, it is going to slice 1. And in department table also, if 10 is, I mean, 10 definitely will be there because department table is the main table for departments. So the 10 values from department table also will come to the same slice. And similarly, in employee table, here T1 means employee, let's say, and department number 20, okay, 20 value, okay, I'm talking about 10, 20, those are all values from department, okay, from employee table, department number 20 is going to slice 2. Then the same department number 20 from department table, okay, T2 means department table, let's say, from the department table also will go to same slice here, for example, slice 2. And similarly, department number 30, okay, from T1, okay, T1 means employee table, is going to slice 3. Then for example, the department table from department table also will go to slice 3. Why? We said that same values will go to same slice, right? Whether it's coming from employee table or department table or any table. If that is the distribution key, same values will go to same slice. Since in both T1 and T2, T1 means here EMP and T2 means DEPT. Both T1 and T2 having distribution key. The distribution key is department number. So department number value, if it is same, they all will go to same slice. Whether that value is from employee table or department table, doesn't matter. Since that is the distribution key, so 10 from T1 will go to whatever slice. 10 from T2 also will go to same slice. 10 from T1 will go to whatever slice. I mean 20, for example, 20 from T2 go to whatever slice. 20 from T1 also go to that slice. Because here it does not matter it's coming from which table, but if that column is the distribution key, same values will go to same slice. That is the way the distribution algorithm works internally. That algorithm is called actually hashing algorithm. Okay, so because how can the values will be distributed to slices? There is something will be working, right? So that the background mechanism is called hashing algorithm. What that hashing algorithm will do is it will distribute, okay, the values to slices. Okay, so that is the reason same values will go to same slice, whether it's coming from table 1 or table 2, as long as that column is same in both the tables. That's the reason joining, if two tables are joining based on same column, and if that column is the distribution key, so matching values will be there in the same slice. So join will happen locally. Okay, cool. All terms will be there from T1 and T2 means table 1 10 also here, table 2 10 also here. Similarly, table 1 20 also here, table 2 20 also here. So matching values you are finding in the same slice itself. So you do whatever join. It may be inner join, left outer, right outer. What is inner join? Matching values. Yeah, matching values are there in the same slice. Just it will take it and give as an output. What is left? I mean, generally in the real time, we'll be either using inner join or left outer, right outer, or full outer. Bus. So, okay, even whether your inner join matching value, what is left outer matching values plus remaining records from left table. So, matching values still required right outer join. Matching values plus remaining records from right table. So, for any join, matching values are required. So, matching values can be easily identified here if it is distribution key in both the tables. So that is the important, I mean that is the reason it's better that joining column is defined as distribution key in both the tables Yeah, in both the tables. So did you understand this till now?
Yes, sir.
Yes.
Somnath?
Yes, I replied it.
Okay. Yeah, now. So I think this is, I mean, the what I'm going to tell is also already understood, but I'm just revising one more time. If the T1 and T2 is not based on same column, then let's say T1 means employee table, right? Employee table is based on some employee ID, okay? Okay, or employee table, T1 is here, I'm taking as employee table, okay? Employee ID is based on employee ID. T2 is the department table, it's based on department number. Okay, so employee ID, so it will be T1 will be distributed based on employee ID. Okay, employee ID 1001, 1002, 1003. Okay, so for example, employee ID 1001 came to slice 1. Okay, but that 1001 belongs to department number 30, let's say. Okay, but department number table distributed based on department number, right? So department number 10 came here. Okay, so from department table, it is department number 10. But from employee table, that record whatever is here, it's from department number 30 here. Okay, so can it match here? Those two, because they are joined based on department table. Can it match here?
No, sir. Not possible.
Somnath, can it match?
No.
Yeah. So at that time, because the department number is 30 in this employee record, but in the department table it has 10, so it cannot match. So since it does not matching, so can we say that there is no matching records for the department number 10? No, they may be there in other slices. So that's why data moment is required for during query processing. So it has to look in other slices if there is any department number 10. So for that, it may move this table, this small, if department number, if department table is small table, it may redistribute small table, or it may duplicate small table on all slices, or it may bring both the tables into disk, something where it can match the records. Because in order to match, it has to do something, right? For example, you are there and I am here. If you want to meet, what we should do? Either I should come to your place, or you should come to my place, or we both should go and meet in some other place. That is bringing to the disk both the tables. So even if I come to you, it involves me some cost. I need to pay some money to, bus or train or flight. Even if you have to come to me, it will charge you. Okay, you have to pay bus, train, flight. And even if you come to, if both of us go to some other place to meet, even it costs for both of us. So all thing is involved with some cost. But if you stay in the same place, it costs nothing. So
So in
we
order
are in
to match,
same place. Yeah.
so in order to match what Redshift will do.
Matching means defining the joining column as the distribution key. Then only it will match.
Suppose 10, the 10 department number is in node 1 and 10 department number for department table is in node 2.
Yeah.
So
At
in
that time, that's what I'm saying. What it will do is, it will either redistribute the table one. That's what Redshift will do. That's what it will place the small. It will see which table is small, and it will try to copy the table into all slices, or it will redistribute the table into all slices based on the joining column. Somehow it will make whatever is required to keep the joining values at one place.
so it is automatically doing, then why we need to specify?
Yeah, that's what it is doing during the query processing. Okay, but During the query processing means your query will run longer, right?
Yeah.
Yeah, but if you already define that small table as the all, it all, so at the time of loading itself, it is placing there in every slice. So during the query processing, that redistribution, this stuff will not be there. Otherwise, that thing need to be happen during query processing.
So this data is kept in slice where in disk or memory.
They are available. I mean, they are placed in slices only, but those slices are connected to disks.
Yeah, so the data is ultimately stored in disk.
Yeah, obviously, right? You see, in disks only you can store terabytes of data. These slices are only for processing.
Yeah, so the data is stored in disk. While processing, will the data be moved to the memory or it will process in disk one?
Yes, it should be moved, right? It should be moved. Otherwise, because only slices only can process, they are the computational units. Okay, it will bring the it will fetch the data from the disk and do whatever processing is need to be done, like joining or aggregating or
So if
filtering.
it's coming to memory, sir, then if all the data is in one place, right? Then there will be not be any issue with joining.
No, because yeah, these concepts are called paging and all in operating system. Yeah, how, but generally main memory you will have maybe, I mean, maybe like some 8 GB or 16 GB or something. But how that 8 GB RAM can process your 1 TB table or 10 TB table? That is called the virtual memory or paging concepts in operating system. Because your table may be like 1 TB or 2 TB, but it does not mean that your RAM also should be 1 TB, 2 TB. Okay, so that it will divide, that's called paging means it will divide that okay, whatever that table into small chunks, and it will execute that in the respective memory. That's why you see here, whatever data is there in the disk, every slice, I mean, because the data is already distributed and stored there through slices only, right? All that 1 TB is distributed are placed in the disk at through slices. So each slice will have access to that part which is loaded. So it will bring that data and it will process, and then it will give back to the user. Okay, and that also will happen through paging and virtual memory using those concepts. So it doesn't mean that slices also should be as long memory as our disk. Otherwise, our data warehouse will have 100 TB. It doesn't mean that we need 100 TB RAM. You understand?
Yeah, okay, sir. Yeah.
You got
Sir,
it?
each slide have a separate disk, sir, in
Hello,
each
just
node.
press a wait. Press a wait. Somnal, you got it?
Yes, sir. Yeah. Got it.
Yeah. Yeah, Prasad, yeah, you're saying?
Each slide have a separate disk, sir. Each and slice.
No, I'll tell you. I'll tell you just a second.
Sir, one more doubt, sir.
Yeah, tell me.
Sir, ఇప్పుడు employee table employee table is unique. Can distribute department table will distribute disk all.
Okay.
Um, all means each node of first slide the copy will be stored, but the second slide will don't have data. Then how can join locally?
Yeah, sorry. Yeah, employee table. Yeah, it is distributed based on some employee ID, and it has some data in the Okay, yeah,
each slices,
in this
but
slice one. Yeah,
yes, department ID will no, use dist all.
yeah,
That means
distribution all
each node of
available in
first
slice one.
slice one,
Yeah,
then slice two. How it possible, sir? Join local joinings. There is no
yeah,
copy of data in second slice.
second slice, right? So yeah, okay. Yeah, okay, good catch. But they are, it is like, we are available in the same village. For example, you and me are available in the same village rather than staying in the same house.
Yes,
Now you understand? So staying in same house is the best. Then next best is staying in the same village.
yes, sir.
So it is not as best as staying in same house, but staying in the same village or same whatever that generally village, same town is next best. Yes or no? Rather than staying in same,
Yes,
I mean
yes,
different
yes, sir.
state.
Yes, sir.
So I mean because it is there in the next slice of the same node. So giving the data or sharing the data is nothing because it is also bringing the data into the memory right during processing.
Yes,
So in the memory, it can share it to the whatever slice two has the employee records to join. You got it right?
yes, yes, sir. Yes, sir.
Yeah. So that's why it is the next best all. For
Okay, sir.
example, you see, yeah. So yeah, we have to use our common sense also. Yeah. Actually, Somnath, you understand what is his question?
Yes, I was going to ask you, like, what was his question?
Yeah. He was saying it's the employee table has distribution style key, right? For example, yeah, key, it has key and it is distributed based on employee table, okay, employee ID, okay. So employee ID will be distributed to slice 1, slice 2, slice 3, slice 4. And let's say slice 1, slice 2 in node 1, okay. Okay, node 1. So node 1 will have slice 1, slice 2, right? So slice 1 will have some employee records and slice 2 will have some employee records. You understand till now, Somnath?
Yes, sir. Yeah.
Yeah. So next department table has, okay, let's say the other table, department table has all distribution style, all distribution style. Okay. So in
Okay.
all distribution style, it is stored in slice one only. I mean, definitely the first slice of each node. So here we have two slices in node one, but the department table is there only in slice one,
Yes.
right? So then how is that? Yeah, slice one is there. So slice one employee records can match with the slice one department table because department table is there in slice one. But how is that employee records of slice two will be joined with the department table because department table is not present in slice two. Department table is there in slice one. But how is that? It is joined with the employee records of slice two because slice two also has employee data, right?
Mm. Yes.
But slice 2 does not have department data because department is there in the slice 1 because it's all distribution style.
Mm.
You got till now?
Yeah, I got it. Yeah, got it.
So that's why I said here employee table and department table are like, staying in the same village rather than in the same house. Same house means staying in the same slice. For example, employee in slice 1, employee records and department table in slice 1, it is like staying in the same house. But employee records in slice 2 and department data in slice 1, they are like in the same village because they are in the same node. So it's easy to meet a person who is residing in the same village. Means it can easily give this copy to the records available in the slice 2. Yes or no?
Yes. So
Yeah,
is it
that's what.
possible, sir,
Yes,
that in
yes, sir.
future
Yes, sir.
Is it possible to view the data in each slide, like on like what data is stored in each slice? Is it possible to query that level?
For us,
Yeah, for us, does
yeah,
Redshift provide any
yeah,
feature?
we can.
Okay.
Yeah, during SQL practice, yeah, we will be able to query.
Yes, we will see that
Okay.
time.
Yeah. Anyway, system tables is one of the important concept. Yeah, I'll be telling what are the system tables, because in entry also it will be asked. No, like generally for troubleshooting all, we need to use system tables. So yeah, we can query. Okay, we can see like yeah, how the data is distributed across all slices, how much data is there in each slice, those things. Okay.
Okay.
Yeah, you understood what Prasad question and how we answered.
Yeah, I understood.
Yeah. So same thing, when you see anywhere we have to use some common sense and some what we call analogy. Okay, I mean how things, this may happen like this may happen like this. We should only assume and justify some things. Here at least it's there in the same, node at least. Okay, but in one slice, department table is there, in other slice department table is not there. But for example, both the tables are distributed based on key. And first of all, department table, all that is not available in any of these slices. Means it is also, let's say both the tables are evenly distributed. Means even with even distribution key. So no slice will have matching records, right? If both the tables are distributed based on even, then none of the slices will have matching record. Then how it's happening? So Redshift is using its own common sense. What it's doing in this case, it will think which table is smaller. Okay, then it will try to duplicate that small table on all slices. Or if two tables are larger, then it may redistribute one of the table, or it may bring both. So it is also using what to do, or what best, how best I can do, like that. So that is Redshift common sense. I mean, common sense means they will design the algorithm like that. Okay, so they will see, so which table is larger, because we should not move larger table, right? So we should always do operations on the smaller table. For example, you see one room is there, 100 kg bag is there, another room is there, 5 kg bag is there. But okay, I mean 5 kg rice bag, and other room is there. Okay, so 100 kg rice, but you need to compare whether both the rice in both the bags is same or not. What you will do, you will bring 100 kg bag to 5 kg bag room, or you will take 5 kg bag to 100 kg bag room. What you will do?
5 kg bags to 100 kg.
Yeah, so that is our common sense. But if you
Yes.
don't have common sense, oh my god, this is the given task, what should I do, what should I do, what you should do. If you don't have common sense, you may think that, oh, 100 kg bag is near me, so let me carry this 100 kg bag to 5 kg bag. Just because it is near you, can you carry, I mean, let's say you can carry with great difficult or something, you may think that I may hire some auto and all. That is stupid. Let me run to 5 kg bag and get that bag. That is simpler. You don't have to hire a auto and all. So I mean, that is what we have to use common sense. Similarly, optimizer, actually at the end of the day, Redshift also programmed right by the engineers, so they will program it like that. Okay, so it will check which table is smaller, and it will come up with the best plan, whether to duplicate or redistribute, or bring both the tables to the disk. So that in order to avoid such kind of things during the processing, that's why this is called advanced table design. You design the tables in such a way that while the loading itself, the data is distributed or stored like that, so that during joins, it will not do this kind of redistribution, duplication, all this stuff, so that it will save you and improve the query performance. That is the funda and that is the summary. You got it?
Yes.
Yes, sir.
Yeah, very, very important. Yeah, so and here another thing is that how the Redshift will distribute the data. What is the mechanism? What is the mechanism? How it will redistribute? How it will distribute the data to all the slices? It uses hashing algorithm. Okay, you should tell that. I mean, just for your information, I'm saying it uses hashing algorithm. Okay. Hello. Okay.
Yes,
It
sir.
uses hash algorithm. That's what your answer should be. Okay. So that hash algorithm only will distribute the data. Okay, while data loading. Okay, and of course the hash. These are all code, internal code. Okay, how the optimizer works. Okay, and that is there in the ladder node. Ladder node will take care. Okay, data distribution and all, and ladder node will know. That's why ladder node. What is the ladder node responsibilities? It will have metadata and all, right? We studied while discussing architecture. It will have metadata, means it knows data about data. It knows all the objects available. It knows which table has how much data or what is the size of the data. It knows what is the distribution keys of the tables. So based on that only it will come up with the best plan. Okay, it knows two tables has what type of distribution style and what is the size of those tables. So based on that it will come up with the best plan, and it will give those steps to the compute nodes. Okay, for example, for example, two tables. Okay, two tables has all distribution style. Okay, two tables has all distribution style. That means both the tables data is available in first slice of each node, right? Two tables has all distribution. Okay, then both the tables has the copy of the data available in first slice of every node, right? Even if it has 10 nodes, yeah, in all the 10 nodes, first slice of node have copy of these two tables. Yes or no?
Yes, sir.
Yeah. So Somnath, you are following, right?
Yes, yes, I am there, sir.
Yeah. So in such case, it does not mean that it will do the join operation in all the 10 nodes. No, because in 10 nodes, first slice, same copies of the both the tables are available. So it will do the operation only in one of the node. Because in the first node, in the first slice, both the tables copy is available. So it just do whatever is matching records there and it will just give the result. You understand how optimizer will think?
Yes, sir.
Yeah, so
Somnath, you understood?
yeah, if the distribution style is even, then while it is round robin, right? So in that case, hashing is not used, right?
Yeah, you see, round robin, but round robin is also will be done by this one only, right? Round robin also will put randomly 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. But that is also we say that hashing. Okay, but yeah, it put randomly. Okay, not based on any particular column.
Okay.
You see, hashing will take one particular value. Okay, and it will hash generally which value, the column which you are defining as a distribution style. Based on that value, it will distribute. But in even, it will not take any column. It will randomly distribute. But that is also we call, hash distribution only, because it's distributing. Okay, but not based on any column. It will distribute automatically. Okay.
Yeah.
Yes, sir.
Okay, cool. So now coming, so this is, so it is very, very important, okay, to select a proper distribution style. Okay, fine. Now tell me what is skew. Tell me what is skew.
Not evenly distribution.
Hey, when you answer like you're giving answer in the interview. Don't tell
Okay.
some parts and bits and words.
Okay. Okay.
Consider this is an interview question and this is an interview. Tell the complete sentence. What is Q? Even if it's wrong also, no problem. Don't worry. Complete sentence, please tell me. What is Q? Prasad, tell me. What is Q?
Yes, sir.
Tell me, brother. What is
Sorry, sir.
Q?
Sorry,
Forgot.
sir. I forgot.
Hey, if I am, talking, for example, let's say strictly or harshly, if you're afraid, or if mind is blank, then how can you people face the interview? Okay, so you see, you should be more thorough with the concept. Otherwise, the new people like you will be like this only. First of all,
Okay.
remove that fear. Nothing will happen. Only two things will happen. Either is select or reject. So don't worry. Be prepared for reject.
Yes, sir.
Okay, because you are just born in IT. Be prepared for reject, but be thoroughly prepared on the subject. Then
Okay.
nothing will happen. You will be selected. No worries, because out of, for example, let's say for Redshift interview, okay, some 30 people are coming. Out of 30 people, let's say, out of 30 people, let's say maybe one or two people are real-time candidates. Even real-time candidates, he may have some working knowledge, but the people who got trained, they will have more knowledge, because theoretical questions real-time people cannot answer generally. For example, Somnath is real-time, working, but he has, no knowledge, because everyone is new. These are all new technologies. Okay, but out of all the people attended, only my people will be selected in the interview. That is proven record from last 10 years. For example, if 8 people went to interview and they selected 5 people, out of 5 my students are 4, and the one person is some very very senior real-time employee. If 4 fake people are selected, those 4 are my batch students only, are my students only. So that is the proven record. In any interview, if at all anyone selected, he is my student only out of all the people attended. So be just present whatever I said. What is Q? Yeah, Somnath, tell me what is Q?
And so by skewness, sir, we understand the uneven distribution of the underlying data.
Yeah, simple. Uneven distribution of data is called skew. Bus. Tell simply, straightforward. Uneven distribution of data is called skew. Okay, think what is happening. Okay, don't mug up like we do in. Okay, what happened? Okay, whenever we are loading data will be distributed to all these slices. Yeah, think like we tell to story to kids, right? So while telling story kids, we don't think, right, or we don't mug up. We tell story with our own words. Okay, whatever comes in the mind, we'll try to frame nicely. Same thing. Okay, Redshift. Okay, Redshift is a distributed architecture. Okay, yeah, distributed architecture meaning it will have MPP architecture. Don't say distributed architecture, MPP architecture. So it will have many compute nodes, and each node there will be many slices. Okay, and all the data will be distributed to the slices. Yeah, definitely, because we are storing all the data into slices, so it's always common sense to have data equally distributed. So definitely data should be distributed, so we should be doing whatever is required in such a way that data will be distributed. So how the data will be distributed based on the distribution case. So we should have a proper distribution case. And what is a proper distribution case? Best is to select the column which is used in the join as the dist key. So that will come under distribution style dist key. Okay, so for small tables, all distribution style. Okay, next one is even auto. If you don't know anything, you can just keep it as auto. Okay, that's fine. So, but what if the data is not distributed evenly with that? What is that called? Skew. Like that, you remember out of in your mind, like you tell a story. Okay, don't mug anything. So in the entry also, because you see, for example, I'll because you say I'll tell one of my experience. You should be like, I told, in the class 2 plus 3 how much. I told, let's say 2 plus 3 5. Then I have seen students, sir, you said 2 plus 3 5, but in the entry he asked for 3 plus 2, sir. I don't know, sir. 3 plus 2. What I will say, boss, 2 plus 3 5 means 3 plus 2 also 5. I mean, okay, so if I said what is skew, I may ask, I may tell like this, what is skew? Like that, for example, I told you like what is skew. Okay, unnamed distribution of data is called skew. Then in the entry, he may ask that, okay, one of my table is, having, for example, slice 1 has 100 records, slice 2 has 5 records, 5 records, 5 records. Can this happen like this? Okay, then you may say, oh, actually data should, you will always say, actually data should be evenly distributed, data should be evenly distributed. You are already, I mean, mugged up, or you brushed your mind like this, data should be evenly distributed. Then you will say, no, it should not happen like that. Then you are fail there. Okay, he is saying 75 records, 5 records, 5 records, and your mind is the data should be always evenly distributed, data should be, and here it's not even distribution, so no, it cannot happen. You will say like that, or you will say that yes, it can happen like that, because there you will do, a head and toss, yes sir, no, yes sir, yes sir, and then you have to say something, so you are saying something, oh no, yes, it can happen. Okay, then he will say, he will think, I mean, interviewer will think sometime and he will say, okay, then what is this called? He will say, what is this called? What is this called? What is this called? This is called skew. My sir did not say what is this called. My sir, what your sir said? Your sir said the uneven distribution of data, and he example he gave is uneven distribution of data, and then and immediately when he is asking what is this called, you should know that he was intending for skew. This is called uneven distribution of data. Okay, the technical term is called skew. That's all. He will be impressed with your presentation. Understand?
Yes, sir.
Yes, sir.
Yeah. So yeah. So one more example I'll give. Okay, I will say that if you see, if you add any number, or if you add 0 to any number, it will be the same number. I mean, I will say in the class, and I will say for example 1 plus 2. I mean, okay, if you add 0 to any number, result will be that same number, and I'll give 1 plus 0 will be 1, because you're adding 0 to 1. And I said that you add 0 to any number, you will get the same number. So 1 plus 0 is 1, 2 plus 0 is 2. Then in the entry he will ask what is 10 plus 0. Then you will think that what is that, my sir did not say 10 plus 0. He said 1 plus 0, he said 2 plus 0, but he did not say 10 plus 0. That's why I'm saying 10, same number I said, right? If you add any number, or if you add 0 to any number, you'll get the same number. So if 1 plus 0 is 1, 2 plus 0 is 2, then 10 plus 0 should be 10. Yeah, well, my point is we have to use, or we have to exercise our common sense. Okay, and for that we should learn the subject like we tell a story to a kid. While telling story to a kid, we don't mug up, right? We know what we want to tell and we will tell, and terms we will just play around. Okay, so like that we should be. Then software job is easy job to get, man. In just 3 months, people are getting starting salary 6 lakhs with some 2 years fake or even 1 year fake nowadays. Starting salary 6.5, 7.5. Okay, you have to do the most hard work. You see, till whatever we studied, it's of no use. We studied some 20 years, paying a lot of money, but the degree certificate is only just for our qualification. That's all, no use. So now you do the real hard work and learn subject. Okay, and Prasad, you take help of Somnath and myself, and take help of Google, YouTube, everything. You do just night and day and night. And if you need any clarification, just take our help and get successful. And
Sure, sir.
nowadays, yeah, people with 5 years are getting 16 to 22 lakhs salary. Somnath, what is your CTC? Hello, Somnath. Hello, Somnath, are you there? You're on mute. Okay, so Somnath, are you there? So no
Yes,
worries.
sir. Yeah, I'm there, sir.
Yeah, yeah. I was asking
Sorry,
what is your CTC. I was asking what is your CTC.
it's above 20.
Okay, cool. So I think even still there is an opportunity. Okay, so to go high. Okay, if you are 20, okay, you can get 30. I mean, you're telling your monthly salary or annual income only, right? 20.
It's a monthly.
What monthly? 20,000?
Yeah, yes.
What, man? I'm telling about lakhs. Okay, so let's say even you're drawing some 50,000, I mean 5 lakhs or 6 lakhs, you can easily get. Okay, you can easily get. I said right, nowadays with 5 years experience, people are getting 18 to 22 lakhs. I'm saying 18 to 22 lakhs. I'm saying, boss, not thousand. Okay, so you can also learn well and get very good job. Okay, 18 to 22 lakhs. I'm saying with 5 years experience people. Okay, so aim for that. And the secret is very simple. Be familiar with the subject thoroughly. That's all. And if you present whatever I said, that's all. That is more than enough. Not more than enough. That is the highest. Okay, but you have to use some common sense. So you see, different people will ask different questions, but in his own style. Okay, so you should understand which topic he is intending, and you should present. Okay, cool. So yeah, now let's come back to yeah, we have seen columnar, and yeah, what is the Redshift? Redshift is a petabyte scale columnar cloud data warehouse, right? And yeah, we also said that Redshift will what happens in the later node? It will come up with the best plan, right? We said it will come up with the best plan. How it will come up with the best plan? Based on the available statistics, I said. Do you remember? Redshift will come up with the best plan based on the available statistics. Do you remember? Hello. we said, right, ladder node will distribute the data to all the slices, and whenever we are running a query, it will know, since where all the data is distributed, it knows all the which is big table, which is small table, how much data is there, and what is the distribution case of all the tables. So it will come up with the best plan to execute this query like that, we said, right? Yes or no?
Yes, sir.
Yeah. How that will come up with that best plan based on the available statistics. Okay. So based on the available statistics. So now the concept will be statistics. Okay. Statistics means in the in Redshift terminology, it is called analyze. Okay. Yeah, actually, I think there should be separate concept on this. Yeah, here. Okay. Yeah, analyze and vacuum. Yeah, we'll be discussing them. Yeah, so that statistics means, yeah, actually it's analyze. Yeah, we'll discuss that maybe, yeah, at the time. So then what is another thing is compression. I'll tell you compression. Yeah, I think compression I also have touched it. I said, right, generally if we're attaching to anything to attachment, if the attachment is too big, what we will be doing? We will be doing compression, right? Yes or no?
Yes, sir.
Yeah. Similarly, in the data warehouse world, tables are generally too big. So, and we are dealing with terabytes of data and petabytes of data. Terabytes means 1000 GB. Petabytes means 1000 TB. So, and if the table is size is large, it will it will have some performance impact, because if the something is big in size, it's very difficult to handle it, right? So that is the reason the data in the Redshift will be automatically compressed. You should know that it is automatically compressed. You don't have to do anything. Okay. So generally the entry question will be, what is compression? Actually, compression is the term in other databases like Teradata, Oracle, MySQL, SQL Server. That is the compression. But here the Redshift terminology is called encoding. They will call what is encoding, or what is encode. That is the question you will get it. Encode means compression. Okay, Redshift will automatically enforce compression for all the tables. You should tell like that. What is encoding? Okay, because we are loading data to tables, so every table will have what? Columns. Columns will define with some data types, right? Employee ID, integer, employee name, varchar, hire date, as date, and all. So this encoding will be applied at the table level. Means at the time of creating a table itself, for example, you see employee ID integer. Okay, so it will have its data type here. Okay, something like LZO. Okay, and department name varchar. Okay, so this is some other. Okay, so this, let's say this is also LZO. Okay, so uh, I mean there are different encoding techniques. For example, you see, I will tell. See, compression encodings. Okay, so the Redshift terminology is encode. Okay, so it's AZ64. Yeah, this is what I was looking for. AZ64. RA means no compression. Okay, so RA, I mean generally every column is compressed. Okay, RA means no compression. AZ64. Okay, LZO. Okay, I mean ZSTD. Yeah, but for most of them, earlier it was LZ64. You see, small int integer, char, var, timestamp and all. But Redshift is always innovating continuously. So the much more advanced compression than LZ2 is AZ64. Okay, so now AZ64 is also used for small int, integer, big int, decimal, timestamp. Okay, generally this AZ64 is used for all integers. See here, integers and timestamp. And the LZ2 is now only for char and var. Char and var. LZ2 is for char and var, for integer, decimal, those things, AZ64. So yeah, and you see, this will be automatically given. You don't have to mention anything. You don't have to remember also anything. Okay.
So encoding is automatic.
Yeah, encoding is automatic. You don't have to define at the time of creating a table. Yeah, you can just create. Okay, no need to mention LZ2 and AZ64 and all. It only will automatically. That's why you just create table as you do in any database, Postgres or Oracle or anything. If you create like that, if you show table, then it will show automatically here like this AZ64. Okay, this is LZ2.
So there are many algorithms, right? So Redshift automatically detects the optimum best one, or we can also use on top of, like, there is some default algorithm that Redshift chooses, and we can use anything if we need above that. Is it something
Yeah,
like that, or?
if you give at the time of creating table like this, it will take whatever you give. Okay. Yeah.
And if we don't
If
give,
you
say, it will have only one algorithm by default, or it can have multiple columns, can have multiple algorithms.
it will take multiple columns. In fact, it will take AZ64 for integers and decimals. Yeah, it will take LZ2 for varchar, and it will take whatever the best and latest available. It will take. In fact, AWS recommends not to give by you, because if you give, it is fixed, it will not be changed. But if you don't give and leave it to Redshift, even in future also, if some new algorithm comes, it will take automatically. Okay, so it is advised and best practice is not to specify by us. Okay, let the Redshift take the latest available encoding. Okay, so got it, Samnath?
Sir.
Yeah, so here the point is, what is encoding? Okay, compression in Redshift is called encoding bus. Okay, encoding will compress the column values and reduces the space, disk space. Why we compress was, we compress to reduce the table size. We are reducing the table size means it will help us to gain some disk space.
But sir, will this increase the query time, or the while querying it will decode?
Query performance also will be increased, right? If the table size is reduced, it's easy to handle during query processing for redistribution, for during joining. Yeah, generally, during joining, some redistributions will happen because all the tables are not created or distributed based on joining column. So yeah, it will help some 15-20% in the performance. Okay, but generally, please remember, encoding is only to optimize the space gain. Okay, it also will contribute to some 15-20% of the performance. Okay, so because encoding is a disk space reducing technique. Okay, encoding, you should talk about encoding for minimizing the disk table size or disk space. Then yes, this question will be asked, does it help the performance? Yes, it do help, because then you should justify, because as the table size is reduced, it will be easy during query processing in case of redistribution, or while moving to the disk space. So it contributes some 15 to 20% of the performance. Okay, but this is not direct performance optimization. Okay, so performance optimization techniques are different. That is, design strategies like distribution keys and all. Table size reducing technique is encoding. Okay, to reduce the table size and to have more disk space, more available disk space. You, for example, you compress the table from 1 TB to 500 GB, then you are saving 500 GB to the customer, right? So in that way it helps to the customers. And obviously when a table is reduced from 1 TB to 500 GB, obviously it will help to some extent for the queries. That some extent is called, I am saying, some 15 to 20%. Yes, it will have some performance benefit for the queries which are using this table. Yeah, you have to use your common sense. I said, right? Common sense exercise, common sense, and give these answers like I saying. Because while think about a table, 1 TB table processing, okay, during peak hours, and think about a table processing 500 GB table. Definitely there is more room available from the database point of view, I mean disk space point of view, and there is some burden of 500 GB on the processor. Okay, so yeah, that's why I said it's majorly into disk space optimization technique. In fact, encoding is to reduce the table size so that we will have more available disk space. Okay, so as part of that, yes, obviously we'll gain some 15 to 20% of the performance, yeah, gain. But this is not directly, in order, for example, if he is asking, oh, can you please tell me what are the steps to improve the query performance, you should not say that I will do encoding, because encoding is not query performance technique. It's to reduce the table size and increase the available disk space. Okay, so that you will have more free space. Obviously when you have more free space, obviously some other queries will be benefited. Okay, up to some 15 to 20%. I mean, just use or present the way I'm saying. Don't tell, yeah, 10% or something. 10% is negligence. Okay, so you just say some 15 to 20% gain will be there. Yeah, like that. Okay.
Yes, sir.
Yes.
Okay, cool. And any questions?
Sir, small question, sir.
Why small question, man? Ask big question only.
సార్ ఇప్పుడు మీరు చూపిస్తున్న టేబుల్ క్రియేట్ టేబుల్ డిపార్ట్మెంట్ నెంబర్ ఇంటిజర్ సార్. ఇప్పుడు ఇంటిజర్ అంటే 4 బైట్స్ సార్. వేర్ క్యాట్ 20, లొకేషన్ వేర్ క్యాట్ 20, టోటల్ 44 బైట్స్ సార్. Is it right,
Okay.
sir? Suppose
Yeah,
you
yeah.
can intimate it, ఎన్కోడింగ్ మీ ఆపరేషన్ చేసినప్పుడు మనం అది 44 బైట్స్ని ఇంకా తగ్గిస్తుంది కదా సార్, డిక్రీజ్
Okay.
దిస్.
Okay. Yeah. Anyway, good question. Good question. Somnath, can you answer this question?
Sir, I understood, but can you translate like what he's trying to say? Like he's saying that integer 4, that will 4 bytes that will decrease if we do compression.
Yeah. Okay. For what he is saying is, you see, this table we have, for example, 3 columns: department number, integer, department name, varchar 20, location varchar 20. So obviously the record size of this table will be integer 4 bytes, department name 20 bytes, location 20 bytes, so 44 bytes. Okay, one record size. Okay, so 44 bytes. Let's say it has some 1000 records, then 44 into 1000, so 44 KB will be its size. Yes or no? You understood till here? 44 KB, because 1000 means K. So 44 KB. So he is saying, if we apply compression to this technique, that 44 KB, yeah, definitely compression will help that 44 KB to be reduced. Okay, I mean, I'm just telling the answer. Okay, forget about answering. I'm telling the compression will actually its size is 44 KB. but because it's encoding, its size is not 44 KB. Its sizes will be around some 28 KB or 24 KB. This Prasad, you understand how the encoding will help us?
Yes,
Table
yes,
size
sir.
will be reduced. Actually, table
Reduce.
size should be yeah, as per the calculation 44 KB table size. But since it is using compression,
And
I mean compression will be
it will be,
automatically used. So it is not 44
it will be
KB,
reduced.
but yeah, so you will see the table size as some 28 KB or 24 KB. But
Yes.
record size calculation will not change. You see, integer size will not change from 4 bytes to 2 bytes, boss. That is a standard. You are only compressing, I mean, the data, but integer will always 4 bytes. Rename varchar 20 will always 20 characters, I mean 20 bytes. Location will always 20. But since you are applying compression, so at the disk level, it will occupy less space while storing at the disk. Okay,
Only
so
record size will reduce.
no. You see, for integer and all same. Okay, integer 4,
Yes.
rename varchar 20, 20, and location varchar 20. Okay, so actually table size is 44 only. Okay, for one record. But
Yes, sir.
while storing at the disk, since it is compressed, it will be stored in within less space because you're compressed and stored in the disk.
Okay. Okay.
So
The entire table data will reduce and store the disk level.
yeah, for example, you see on a desktop, I have a file. Okay, so that file is, let's say, I mean, for example, you take this, yeah, some 232 KB. Okay, but if you compress, its size is reduced. Okay, so while compressing, so does that mean that it got size got reduced? So are some data got, I mean, lost or something? No, right? Compress means it will just press it and store it. That's all. But integer, okay, varchar, their sizes will not be changed.
Okay, sir. Okay, sir.
Okay, so because those are the data types, and that will take that much amount of space only for storing. But the compression will be acting on the disk. Disk means physical. Okay, so while storing, same thing, like how do we compress? How do we compress? For example, this Teradata folder is there. It is something like size 2.10 MB. Okay, so but if I compress, I think can I compress? Yeah, compress to compressed zipped folder. What happens? Everything will be compressed and it will show some other size. Okay, on the disk, how much time, how much space. So does it mean that the sizes of the inside folders are reduced? No, they will be there, but while storing on that, yeah, so it will reduce the overall size. Okay, yeah, but in the table we are dealing with the data types and all, so data types and all, it will not get changed. Okay, but compression will help to reduce the size on the disk while storing. Disks means here, yeah, everything here is stored in on S3. So on S3, it will reduce the table size. In Redshift or in cloud, or especially in AWS, we call it as S3. So that's where that is our disk actually. Whatever disk space is there, it will occupy less space. So that on S3 we will be charged basically that charge will be cost will reduce for us. Okay, S3 storage cost will be reduced. That's the reason it will automatically apply the compression. Okay, so it will not affect the size of the integer and size of varchar and all.
Data types.
Okay,
Yes, sir. Got it, sir.
okay, cool. Any other questions? You have questions or you don't have questions? Both of you.
No, sir.
No.
Okay. Then tell me when should we meet?
So whenever you want.
Okay. No.
I'm free
Actually,
tomorrow.
tomorrow. Actually, yeah. Anyway, tomorrow and after tomorrow we have weekend, right?
Okay.
So Sunday. Can we meet Sunday because I'm not available on Monday and Tuesday. Or I mean, it's
Okay.
up to you.
Yeah, we
I
can.
mean, can we meet Sunday? Because I'm
Yes,
not
sir.
available Monday and
Yes, sir.
Tuesday.
Yes, sir.
Huh?
No
Yes,
problem,
sir.
sir.
Yeah, we'll meet on Sunday. Is that fine?
Yes, sir.
Yeah, Sunday. Same time?
What time, sir?
Sunday, I think 10 a.m. Same thing. On weekend, we'll have some relax. 10 a.m.
Yeah, sure.
Okay, sir. No. Okay, sir. No problem.
I mean, I'm okay. 9 a.m. also, I'm okay. Sunday. Oh, sorry, boss. Actually, the actual thing is I'm going for visa stamping. Okay. So I may not carry my laptop. This is personal laptop. Oh, sorry. Let me off the recording. So,